What if everything you've ever known, every memory, every choice, every law of nature was just one version of reality? What if somewhere out there, an alternate version of you is living a completely different life, shaped by decisions you never made? This isn't just the stuff of science fiction. The idea of parallel universes and alternate dimensions has fascinated scientists, philosophers, and dreamers for centuries, pushing the boundaries of what we think is possible. Today, we're diving into the mind-bending world of these hidden realities, exploring the science behind them, the theories that challenge our understanding of existence, and the tantalizing possibility that we're not alone in the universe, just one of countless versions of ourselves. From the strange quirks of quantum mechanics to the speculative edges of cosmology, this journey will take you to places where reality itself begins to unravel. So, buckle up. What you're about to discover might just change the way you see everything. To truly grasp the idea of parallel universes, we need to dive into the science that makes them more than just a wild idea. It all starts with quantum mechanics, the branch of physics that deals with the strange and unpredictable behavior of particles at the smallest scales. One of the most fascinating theories to emerge from this field is the many worlds interpretation. Picture this: every time you make a decision, whether it's what to eat for breakfast or which path to take in life, the universe splits. In one version, you choose the toast. In another, you go for the cereal. This isn't just a fun thought experiment, it's a serious proposal that suggests every possible outcome of every event actually happens, but in separate, branching realities. But the many worlds interpretation isn't the only theory that hints at parallel universes. String theory, for example, takes us even further. It suggests that our universe might be just one of many branes, like slices of bread in a cosmic loaf floating in a higher dimensional space. These branes could contain entirely different universes with their own laws of physics, completely separate from ours. And then there's the multiverse hypothesis, which proposes that our universe is just one bubble in an infinite foam of universes, each with its own unique properties. What's incredible about these theories is how they challenge our everyday understanding of reality. We're used to thinking of the universe as a single, cohesive entity, but science is showing us that it might be far more complex and far stranger than we ever imagined. These ideas don't just expand our horizons, they force us to rethink what it means to exist. Could there be a version of you out there who made different choices? A version of Earth where history unfolded in a completely different way. The possibilities are as thrilling as they are mind-bending. As we explore these theories, it's important to remember that they're still just that, theories. Scientists are working hard to test and refine them, but for now, they remain at the cutting edge of our understanding. Still, they offer a glimpse into how science continues to push the boundaries of what we think is possible, inviting us to dream bigger and ask deeper questions about the nature of reality itself. Now, let's take a closer look at the quantum world, a place where the rules of reality seem to bend and twist in ways that defy our everyday experiences. At the heart of quantum mechanics lies a concept called superposition. This is the idea that particles, like electrons or photons, can exist in multiple states at once until they're observed. It's as if a coin is spinning in midair, neither heads nor tails, until it lands and you see the result. But here's where it gets even wilder. According to some interpretations, every possible outcome of that quantum event doesn't just vanish into thin air. Instead, each outcome creates a new universe branching off from the original. This idea is famously illustrated by Schrödinger's cat, a thought experiment that's as puzzling as it is iconic. Picture a cat in a sealed box with a device that has a 50-50 chance of releasing poison. According to quantum mechanics, until you open the box, the cat exists in a superposition, both alive and dead at the same time. It's only when you observe the cat that the wave function collapses and one reality becomes definite. But the many worlds interpretation takes this a step further, suggesting that both outcomes actually happen, just in separate universes. In one world, the cat lives, in another, it doesn't. But superposition isn't the only quantum phenomenon that hints at the multiverse. Quantum entanglement, where particles become linked no matter how far apart they are, adds another layer of mystery. When two particles are entangled, measuring one instantly affects the other, even if they're light years apart. This spooky action at a distance, as Einstein called it, challenges our understanding of space and time. Some scientists speculate that entanglement could be a window into parallel realities, where particles in different universes are somehow connected. And then there's the concept of wave function collapse, the moment when a quantum system shifts from multiple possibilities to a single, observable state. In the context of the multiverse, this collapse doesn't eliminate the other possibilities, it simply means they continue to exist in alternate realities. It's like flipping a switch and realizing that every possible position the switch could have been in still exists somewhere, just not in your version of reality. These quantum phenomena paint a picture of a universe far stranger and more complex than we might have imagined. They challenge us to rethink not just the nature of reality, but also our place within it. If every quantum event spawns new universes, does that mean there's a version of you out there who made every possible choice? A version of the world where history unfolded in ways you can't even begin to imagine. The implications are staggering, and they open up a universe of questions that science is only beginning to explore. What's remarkable is how these ideas, born from the tiniest particles, ripple out to reshape our understanding of existence itself. They remind us that reality might not be as fixed or singular as we once thought, and that the universe might be far more vast and interconnected than we ever dreamed. Now, let's shift our focus to string theory, a framework that takes the concept of parallel universes into uncharted territory. Imagine the universe not as a flat, three-dimensional space, but as something far more intricate, a cosmic tapestry woven with hidden dimensions. String theory suggests that beyond the familiar length, width, and depth we experience, there could be up to 10 or even 11 dimensions, all curled up and hidden from our perception. These extra dimensions aren't just theoretical, they're essential to the very fabric of the theory, offering a way to unify the forces of nature and explain the fundamental building blocks of reality. At the heart of string theory is the idea that everything in the universe, every particle, every force is made up of tiny, vibrating strings. These strings aren't like the strings on a guitar. They're unimaginably small, vibrating at different frequencies to create the particles and forces we observe. But here's where it gets even more fascinating. These strings don't just exist in our three-dimensional space. They move through higher dimensions, dimensions we can't see, but that might hold the key to understanding the multiverse. One of the most intriguing aspects of string theory is the concept of branes, short for membranes. Picture our universe as a three-dimensional brain floating in a higher dimensional space, like a slice of bread in a cosmic loaf. But our brain isn't alone. There could be countless other brains out there, each hosting its own universe with its own unique laws of physics. These brains might exist so close to each other that they're practically overlapping, yet we'd never know it because they're separated by dimensions we can't perceive. What's even more mind-blowing is the idea that these brains could collide. When two brains smash into each other, the energy released could be so immense that it spawns an entirely new universe. Some scientists even suggest that our own universe might have been born from such a collision, a cosmic event that could explain the Big Bang itself. It's a breathtaking idea, the birth of our universe not as a singular, isolated event, but as part of an endless cycle of collisions and creations in a multidimensional multiverse. String theory doesn't just stop at explaining the origins of universes. It also offers a potential framework for understanding how different realities might coexist. If our universe is a brane floating in a higher dimensional space, what's to stop other branes from hosting entirely different versions of existence? Universes where gravity is stronger, where time flows backward, or where the laws of physics are completely alien to us, the possibilities are as vast as the hidden dimensions themselves. Of course, string theory is still a work in progress. It's one of the most complex and challenging areas of modern physics, and scientists are still working to gather evidence to support its predictions. But even in its current state, it offers a tantalizing glimpse into the potential structure of reality. It challenges us to think beyond the limits of our senses, to imagine a universe or multiverse far richer and more intricate than we ever thought possible. As we peel back the layers of string theory, we're reminded just how much there is to discover. The universe, it seems, is far stranger and more interconnected than we once believed. And with each new theory, each new insight, we're not just exploring the cosmos, we're redefining what it means to exist within it. Imagine a world where every decision you've ever made and every decision you could have made exists simultaneously, unfolding in countless parallel realities. This isn't just a sci-fi fantasy, it's the core idea behind the many worlds interpretation, a theory that redefines how we understand the universe. At its heart, this interpretation suggests that every possible outcome of a quantum event doesn't just vanish into uncertainty, it actually happens, but in a separate, branching universe. To understand how this works, let's take a closer look at the double slit experiment, a cornerstone of quantum mechanics. In this experiment, particles like electrons or photons are fired at a barrier with two slits. When unobserved, these particles create an interference pattern on the other side, behaving like waves. But the moment you try to measure which slit the particle goes through, the interference pattern disappears and the particle behaves like a single, discrete object. Traditional interpretations of quantum mechanics explain this by saying the act of observation collapses the wave function, forcing the particle to choose a state. But the many worlds interpretation offers a radical alternative. The wave function never collapses. Instead, every possible outcome occurs, each in its own distinct universe. In one universe, the particle goes through the left slit. In another, it goes through the right. And in countless other universes, every other possible path is realized. This means that instead of a single, linear timeline, reality is more like an endlessly branching tree, with every quantum event creating new branches. What's particularly striking about this interpretation is how it shifts our perspective on determinism. In the classical view, the universe unfolds in a single, fixed sequence of cause and effect. But in the many worlds framework, everything that can happen does happen somewhere. This doesn't mean our choices are meaningless. It simply means that every choice leads to a new reality. This idea also raises profound questions about free will. If every possible decision you could make is playing out in some parallel universe, does that mean your choices are predetermined? Or does it mean that every version of you is exercising free will in their own unique way? The many worlds interpretation doesn't provide easy answers, but it forces us to rethink the very nature of decision-making and existence. What's remarkable is how this theory eliminates the need for wave function collapse, a concept that has long puzzled physicists. Instead of a mysterious process that chooses a single outcome, the many worlds interpretation offers a more elegant solution. All outcomes exist, just in different branches of reality. This approach aligns with the deterministic nature of the equations of quantum mechanics, which don't require any collapse to make sense. Of course, this interpretation isn't without its critics. Some argue that it's untestable since we can't observe these parallel universes directly. Others question whether the idea of infinite branching realities is even scientifically meaningful. But for many, the many worlds interpretation offers a compelling way to reconcile the strange behavior of quantum particles with a more unified view of reality. As we wrestle with these ideas, one thing becomes clear. The many worlds interpretation doesn't just challenge our understanding of physics, it challenges our understanding of ourselves. If every quantum event spawns new universes, then every moment of your life is a crossroads, a point of infinite possibilities. It's a perspective that's as humbling as it is exhilarating, reminding us just how vast and mysterious the cosmos truly is. The idea of parallel universes isn't just the domain of scientists and philosophers, it's a concept that has sparked the creativity of storytellers for decades. From blockbuster movies to beloved TV shows, parallel universes have become a staple of popular culture, offering endless possibilities for imagination and exploration. Think about Marvel's Multiverse, where every timeline, every decision, and every reality branches off into its own unique story. Or consider the eerie alternate dimension in Stranger Things, where the upside down mirrors our world in unsettling ways. These fictional portrayals aren't just entertainment, they're reflections of humanity's deep curiosity about what lies beyond the familiar. Take The Matrix, for example. This groundbreaking film introduced audiences to the idea that our reality might be a simulation, a constructed world designed to hide a deeper truth. It's a concept that echoes certain scientific theories about the nature of existence, blurring the line between fiction and possibility. Similarly, Inception takes us on a journey through layers of dreams, each one a distinct reality with its own rules. These stories tap into our innate desire to question the world around us, to wonder if there's more to life than what we see. Books, too, have played a huge role in shaping how we think about parallel universes. Philip K. Dick's The Man in the High Castle imagines a world where the Axis powers won World War II, offering a chilling glimpse into what might have been. Meanwhile, Neil Gaiman's Coraline explores a darker, twisted version of reality that feels both familiar and deeply unsettling. These stories don't just entertain, they challenge us to consider how small changes can lead to vastly different outcomes, a theme that resonates with the scientific concept of branching timelines. What's fascinating is how these fictional portrayals influence the way we think about real scientific theories. When a TV show like Rick and Morty dives into the multiverse, it sparks conversations about quantum mechanics and alternate dimensions. It's not just about the laughs or the drama, it's about planting seeds of curiosity that can grow into a deeper interest in science. Films like Interstellar take this a step further, weaving complex scientific ideas into their narratives and inspiring viewers to learn more about the cosmos. But it's not just about science. These stories also reflect our collective fears, hopes, and dreams. They allow us to explore what it would mean to live in a world where anything is possible, where the choices we make or don't make could lead to entirely different lives. In Sliding Doors, for instance, we see how a single moment, like missing a train, can set two parallel realities in motion. It's a reminder of how fragile and interconnected our lives can be, and how even the smallest decisions can have profound consequences. As much as these stories entertain, they also inspire real-world exploration. Scientists and thinkers often draw on the creativity of fiction to push the boundaries of what we know. The multiverse in Marvel might be fantastical, but it's not so far removed from the ideas being explored in theoretical physics. And while the upside down in Stranger Things is a work of fiction, it captures the same sense of mystery that drives scientists to study the unknown. Ultimately, the power of these stories lies in their ability to make the unimaginable feel real. They take complex ideas and bring them to life in ways that are accessible, engaging, and deeply human. Whether it's through the lens of a superhero movie or a dystopian novel, parallel universes in pop culture remind us that reality might be far stranger and far more wondrous than we ever thought possible. By blending science and storytelling, these fictional worlds don't just entertain, they invite us to dream bigger, to question what we know, and to imagine what might be waiting just beyond the edges of our understanding. Black holes have long captured our imagination, not just as cosmic anomalies but as potential gateways to the unknown. These enigmatic objects, where gravity is so intense that not even light can escape, might hold the key to bridging our universe with alternate dimensions or parallel realities. The idea that black holes could serve as portals isn't just science fiction, it's rooted in some of the most intriguing theories in modern physics. One of the most compelling ideas is the concept of wormholes, often referred to as Einstein-Rosen bridges. These hypothetical tunnels through space-time could connect two distant points in the universe, or even two entirely different universes. Imagine folding a piece of paper so that 2 points touch. A wormhole would be like poking a hole through that fold, creating a shortcut. While wormholes are still theoretical, they're mathematically possible within the framework of general relativity, and black holes, with their immense gravitational pull, are thought to be prime candidates for forming or hosting these cosmic shortcuts. But wormholes aren't the only way black holes might connect us to alternate dimensions. The holographic principle offers another tantalizing possibility. This theory suggests that all the information contained within a volume of space can be represented as a hologram on its boundary. In the context of black holes, this means that the event horizon, the point of no return, could act like a two-dimensional surface encoding the entire three-dimensional reality inside. Some scientists speculate that this holographic boundary might not just describe our universe but could also link to other realities, effectively making black holes gateways to alternate dimensions. The extreme conditions near a black hole's event horizon also play a crucial role in these theories. The intense gravitational forces distort space-time to such an extent that the very fabric of reality begins to warp. Time slows down and space stretches in ways that defy our everyday experiences. It's within these extreme environments that the rules of physics as we know them start to break down, opening the door to phenomena we can barely imagine. Could these distortions create pathways to other universes? Some researchers believe so, suggesting that the singularity at the center of a black hole might not be an endpoint but a bridge to something entirely different, a new dimension, a new reality, or even a new set of physical laws. If black holes truly are gateways to alternate dimensions, the implications are staggering. They could revolutionize our understanding of space travel, offering a way to traverse vast cosmic distances in the blink of an eye. Imagine a future where humanity uses black holes as cosmic highways, exploring not just distant stars but entirely different universes. It's a vision that blends the speculative edges of science with the boundless possibilities of human ingenuity. And then there's the search for extraterrestrial life. If alternate dimensions exist, could they be teeming with civilizations we've never encountered? Some theories suggest that advanced alien species might already be using black holes as portals, traveling between dimensions in ways we can't yet comprehend. This idea adds a new layer to the Fermi paradox, the question of why we haven't found evidence of extraterrestrial life. Perhaps the answer lies not in the stars above us but in the hidden dimensions beyond our perception. Of course, these ideas are still on the cutting edge of science. Black holes remain some of the most mysterious objects in the universe, and the theories surrounding them are far from proven. But that's what makes this exploration so exciting. every new discovery, every new insight brings us closer to understanding the true nature of these cosmic enigmas and the role they might play in connecting us to realities we've yet to imagine. As we peer into the depths of a black hole, we're not just looking at a void, we're glimpsing the edge of possibility. It's a reminder that the universe is far stranger, far more interconnected, and far more wondrous than we ever thought. And who knows, perhaps one day black holes won't just be objects of study, they'll be our gateway to the infinite. Time travel has always been one of the most tantalizing ideas in science fiction, but what if it's more than just a fantasy? What if the ability to move through time isn't just a plot device, it's a real possibility, deeply connected to the concept of alternate timelines and parallel universes? To explore this, let's start with one of the most famous thought experiments in time travel, the grandfather paradox. Imagine you travel back in time and prevent your own grandfather from meeting your grandmother. If they never meet, your parents are never born, and neither are you. But if you don't exist, how could you have traveled back in time to change the past in the first place? This paradox seems to create an unsolvable loop, but what if the answer lies in alternate timelines? According to the many worlds interpretation, every time you make a decision, or in this case, every time you travel through time, you create a new branch of reality. So if you go back and alter the past, that change doesn't erase your original timeline. Instead, it spawns a new one where the altered events play out independently. In this new timeline, your grandparents might never meet, and you might never be born. But in the original timeline, you still exist, untouched by your actions. This idea not only resolves the grandfather paradox, but also suggests that time travel could be a mechanism for creating entirely new realities. But how could time travel even be possible? One intriguing concept is the idea of closed time-like curves, or CTC. These are theoretical pathways through space-time that loop back on themselves, allowing an object or a person to travel back to their own past. CTCs are mathematically possible within the framework of general relativity, although they require extreme conditions like the intense gravitational fields near a black hole or the presence of exotic matter with negative energy. If CTCs exist, they could provide a way to travel through time without breaking the laws of physics. The idea of CTCs isn't just theoretical, it's been explored in some of the most cutting-edge research in physics. For example, physicist Kip Thorne has proposed that wormholes, those hypothetical tunnels through space-time, could be stabilized and used as time machines, creating a CTC that connects 2 points in time. While this remains speculative, it's a fascinating possibility that bridges the gap between science fiction and real science. Of course, time travel isn't without its challenges. Even if CTCs or wormholes could exist, the energy requirements and technological hurdles would be immense. And then there's the question of causality, the relationship between cause and effect. If you could travel back in time and change the past, would the universe find a way to preserve causality, or would it allow for paradoxes? Some theories suggest that the universe might enforce a kind of cosmic censorship, preventing actions that would create logical inconsistencies. Others propose that every action in the past would simply create a new timeline, leaving the original sequence of events intact. What's remarkable about these ideas is how they blur the line between time and space, suggesting that the two are more intertwined than we might think. Just as alternate universes could exist alongside our own, alternate timelines might branch off from every moment, creating a web of realities that stretch across time itself. It's a perspective that challenges our linear view of history, suggesting that the past, present, and future might all coexist in a vast, multidimensional tapestry. As we ponder these possibilities, it's worth asking, what would time travel mean for us as individuals? If alternate timelines exist, does that mean every decision we make or don't make could lead to a new version of reality? Could we, in theory, revisit our past and explore what might have been? These questions don't just push the boundaries of science, they touch on something deeply human, our desire to understand our place in the universe and our longing to explore the infinite possibilities of existence. Time travel might still be a distant dream, but the theories surrounding it remind us just how much there is to discover. They invite us to think beyond the limits of our everyday experience, to imagine a universe where the past, present, and future are all part of a grand, interconnected whole. And who knows, maybe one day the lines between science fiction and reality will blur even further, and we'll find ourselves stepping into the unknown, not just across space but through time itself. What if everything around you, the trees, the stars, even the air you're breathing, isn't real? What if your life, your memories, and the entire universe are nothing more than lines of code in a vast, hyper-advanced simulation? This isn't just a plot twist from the Matrix, it's a serious idea that's been debated by scientists, philosophers, and futurists alike. Known as the simulation hypothesis, this theory suggests that our reality might be an artificial construct created by a civilization far more advanced than our own. And if that's true, it opens up a whole new world of possibilities, including the idea that there could be countless other simulations running alongside ours, each with its own unique version of reality. Let's break this down. The simulation hypothesis gained mainstream attention thanks to figures like philosopher Nick Bostrom, who proposed a compelling argument in 2003. He suggested that if a civilization reaches a point where they can create simulations indistinguishable from reality, it's statistically likely that we're living in one of those simulations rather than the original, base reality. Think about it. If you could create a universe in a computer, why stop at one? You could run billions, each with its own set of rules, inhabitants, and histories. But how does this tie into parallel universes? If our universe is a simulation, it's not a stretch to imagine that other simulations exist, each one a parallel universe with its own unique parameters. These simulated realities could be running simultaneously, stacked like layers in a cosmic computer. Some might resemble our own, with slight variations, like a world where dinosaurs never went extinct or where humans never evolved. Others could be wildly different, with alien physics, alternate dimensions, or even sentient beings we can't begin to comprehend. From a scientific perspective, the simulation hypothesis raises fascinating questions. Some researchers argue that if our universe is a simulation, there might be subtle glitches or anomalies that give it away. For example, tiny inconsistencies in the behavior of particles or the fabric of space-time could be evidence of underlying code. Others point to the limits of computing power, suggesting that simulating an entire universe at the level of detail we experience would require resources far beyond anything we can imagine. On the philosophical side, the simulation hypothesis challenges our understanding of consciousness and existence. If we're living in a simulation, does that make our experiences any less real? Does it change the meaning of life, free will, or morality? These are questions that don't have easy answers, but they push us to think deeply about what it means to exist, whether in a simulated world or a base reality. Critics of the hypothesis argue that it's untestable and relies on assumptions that can't be proven. After all, if a simulation is perfect, how would we ever know we're inside it? Others point out that even if we are living in a simulation, it doesn't necessarily change the way we live our lives. Whether we're made of atoms or algorithms, our experiences, relationships, and struggles still feel profoundly real to us. What's truly intriguing is how the simulation hypothesis intersects with the concept of parallel universes. If multiple simulations can exist, each with its own rules and realities, then the multiverse might not just be a product of physics, it could be a product of technology. Imagine a future where humanity itself becomes the creator of simulations, crafting universes as easily as we write code today. In that scenario, the line between creator and creation, reality and simulation becomes increasingly blurred. As we explore these ideas, one thing becomes clear. The simulation hypothesis doesn't just challenge our understanding of the universe, it challenges our understanding of ourselves. It forces us to confront questions about the nature of reality, the limits of knowledge, and the possibility that we might be living in a world far stranger than we ever imagined. So, the next time you look up at the stars or feel the warmth of the sun on your skin, take a moment to wonder, is this real, or is it just one of countless simulations, each a thread in the infinite tapestry of existence? The answer might be out of reach for now, but the journey to find it is as thrilling as it is humbling. What if the key to unlocking the secrets of parallel universes has been hiding in plain sight all along right here in our own cosmos? Enter dark matter, the elusive substance that makes up about 85% of the universe's mass. Yet, despite its overwhelming presence, we've never directly observed it. It doesn't emit light, absorb energy, or interact with the electromagnetic forces we're familiar with. So how do we know it's there? The answer lies in its gravitational effects. Dark matter's invisible pull shapes galaxies, bends light, and holds the cosmos together. But what if this mysterious substance isn't just a ghostly presence in our universe? What if it's a clue pointing us toward the existence of parallel realities? One of the most intriguing theories suggests that dark matter might actually be matter from another dimension, a neighboring universe brushing up against ours. Imagine two sheets of paper lying flat on a table. If you press down on one sheet, the other might ripple or shift slightly, even though they're not directly touching. In the same way, dark matter could be the gravitational fingerprint of a parallel universe, subtly influencing our own. This idea isn't just speculative, it's grounded in some of the most advanced theories in physics, including the concept of branes, those higher dimensional membranes we explored earlier in string theory. If our universe is a brane floating in a higher dimensional space, dark matter could be the gravitational echo of another brane nearby. But how could we possibly detect something from another dimension? The answer might lie in the way dark matter interacts, or rather, doesn't interact with the forces we know. While ordinary matter is governed by electromagnetism, the strong and weak nuclear forces, and gravity, dark matter seems to respond only to gravity. This unusual behavior could be explained if it's part of a different set of physical laws that apply in a parallel universe. In other words, dark matter might be the only part of that other reality that leaks into ours, giving us a tantalizing glimpse of what lies beyond. Recent research has added even more fuel to this idea. Scientists studying the distribution of dark matter in the universe have noticed something strange. It clumps together in ways that don't always align with the visible matter we can observe. Some theorists argue that these irregularities could be evidence of interactions between our universe and another. Picture a cosmic dance where the gravitational pull of an unseen partner, a parallel universe, shapes the movements of dark matter in ways we're only beginning to understand. Of course, these ideas are still in the realm of theory, and dark matter remains one of the most challenging puzzles in modern science. But the possibility that it could be a bridge to parallel universes is too compelling to ignore. If dark matter truly is the gravitational shadow of another reality, it would revolutionize our understanding of the cosmos. It would mean that the universe we see is just one layer of a much larger, more complex tapestry, a multiverse where countless realities coexist, each influencing the others in ways we're only starting to uncover. As we continue to study dark matter, we're not just searching for answers about our own universe, We're peering into the unknown, asking questions that could reshape everything we thought we knew. What if the key to understanding parallel universes has been right in front of us all along, hidden in the invisible threads that hold the cosmos together? The journey to find out is as thrilling as it is humbling, reminding us just how much there is to discover in the vast, interconnected web of existence. The universe is unimaginably vast, with billions of galaxies, each containing billions of stars and planets. Given these staggering numbers, the odds seem overwhelmingly in favor of extraterrestrial life existing somewhere out there. Yet, despite decades of searching, we've found no definitive evidence of other civilizations. This puzzling contradiction is known as the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody? If the universe is so full of possibilities, why haven't we encountered even a single alien signal?" One intriguing possibility is that the answer lies not in our universe but in others. Parallel universes might hold the key to solving this cosmic mystery. If alien civilizations exist, they might not be in our reality at all. Instead, they could thrive in alternate dimensions, completely isolated from us by the fabric of space-time. The multiverse theory suggests that our universe is just one of countless others, each with its own unique laws of physics and conditions for life. In some of these universes, intelligent life might have evolved in ways we can't even imagine, flourishing in environments that would be utterly alien to us. But because these realities are separated from ours by dimensions we can't access or detect, contact becomes impossible. This idea offers a fascinating twist on the Fermi paradox. Instead of assuming that extraterrestrial life should be visible in our universe, we might need to consider that it's hidden in plain sight, just not in our version of reality. It's like living in a house with walls so thick that you can't hear your neighbors, even if they're right next door. The multiverse could be filled with life, but the barriers between universes make it invisible to us. But what if some of these alternate realities are closer than we think? The concept of branes in string theory suggests that other universes could exist just millimeters away from ours, separated by dimensions we can't perceive. In these neighboring realities, alien civilizations might be thriving, completely unaware of our existence, and we, in turn, might never detect them. This raises the possibility that the silence we hear in our search for extraterrestrial intelligence isn't a sign of loneliness but a consequence of the multiverse's vast hidden structure. Another angle to consider is the role of physical laws in shaping life. In our universe, the constants of nature, like the speed of light or the strength of gravity, are finely tuned to allow for the existence of stars, planets, and life as we know it. But in other universes, these constants might be different. Some might be too chaotic to support life, while others could foster civilizations far more advanced than our own. If intelligent life exists primarily in universes with different physical laws, it would explain why we haven't found it in ours. The multiverse theory doesn't just offer a solution to the Fermi paradox. It also challenges us to rethink what it means to search for extraterrestrial intelligence. If life exists in parallel realities, our current methods of detection, like scanning for radio signals or looking for biosignatures on distant planets, might be fundamentally limited. Instead, we might need to explore entirely new ways of probing the boundaries of our universe, searching for clues that could hint at the presence of other dimensions. As we grapple with these ideas, one thing becomes clear. The Fermi paradox isn't just a question about aliens, it's a question about the nature of reality itself. Are we alone because life is rare, or are we simply looking in the wrong places? The multiverse theory opens up a universe of possibilities, reminding us that the answers we seek might lie beyond the limits of our imagination. So, the next time you gaze up at the night sky and wonder why it feels so empty, remember, the cosmos might be far more crowded than we think. It's just that the neighbors are living in a reality we can't yet reach. The search for extraterrestrial intelligence isn't over. It's just beginning to expand into dimensions we've only started to explore. And who knows, the key to solving the Fermi paradox might not be out there among the stars. It might be hiding in the spaces between realities, waiting for us to find it. Consciousness, what it is, how it works, and why it exists remains one of the greatest mysteries of science and philosophy. It's the very essence of our experience, the lens through which we perceive reality. But what if that lens isn't confined to a single dimension? What if consciousness extends beyond the boundaries of our universe, connecting us to parallel realities we can't yet perceive? This idea might sound like the stuff of science fiction, but it's a theory that's gaining traction among some of the most forward-thinking scientists and philosophers. One of the most intriguing ideas comes from the intersection of quantum mechanics and neuroscience. The ORCH, or theory, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, suggests that consciousness arises from quantum processes within the brain. Specifically, they propose that tiny structures called microtubules found in our neurons might facilitate quantum vibrations that give rise to conscious experience. If this is true, it opens the door to a mind-bending possibility. These quantum processes could link our consciousness to other dimensions or universes. Imagine your thoughts and experiences as ripples on the surface of a vast quantum ocean. In this view, consciousness isn't just a product of your brain, it's a phenomenon that transcends space and time, potentially connecting you to alternate versions of yourself in parallel realities. This idea aligns with the many worlds interpretation of quantum mechanics, which suggests that every decision you make creates a new branch of reality. If consciousness is quantum in nature, could it exist simultaneously across all those branches? Could there be a version of you in another universe experiencing a completely different life, yet somehow connected to the consciousness you know as you? Philosophers have long pondered the nature of consciousness, and some have suggested that it might not be tied exclusively to the physical brain. The concept of panpsychism, for example, proposes that consciousness is a fundamental property of the universe, like mass or charge. If this is true, then consciousness might be woven into the fabric of reality itself, present in every particle and every dimension. In this framework, our individual experiences of consciousness could be like drops of water in an infinite ocean, each one connected to the whole but distinct in its own way. This leads us to another fascinating idea, the possibility of shared or collective consciousness across parallel universes. If consciousness is a universal property, could there be a form of awareness that spans multiple realities? Some theories suggest that near-death experiences or moments of profound insight might be glimpses into this larger, interconnected consciousness. These fleeting moments could be windows into other dimensions, where the boundaries between you and the universe blur, revealing a deeper, more unified reality. Of course, these ideas are still speculative, and the nature of consciousness remains a deeply complex puzzle. But what's exciting is how they challenge us to think beyond the limits of our current understanding. They invite us to consider that consciousness might not be confined to the brain or even to this universe. Instead, it could be a bridge, a link between dimensions, a thread that weaves through the multiverse, connecting us to realities we've only begun to imagine. As we explore these theories, we're reminded just how much there is to discover, not just about the universe, but about ourselves. Consciousness is more than a scientific question. It's a deeply personal one, touching on the very essence of who we are. Whether it's rooted in quantum vibrations, universal properties, or something beyond our current comprehension, the nature of consciousness might hold the key to understanding not just our place in the cosmos, but the very fabric of existence itself. So, the next time you pause to reflect on your thoughts or marvel at the richness of your inner world, consider this. Your consciousness might be far more vast, more interconnected, and more mysterious than you ever imagined. It's a reminder that the universe, and perhaps even the multiverse, isn't just out there. It's within you, waiting to be explored. If the universe is a symphony, then mathematics is its sheet music, a precise, elegant language that reveals the hidden patterns and rhythms of reality. And when it comes to understanding the multiverse, mathematics isn't just a tool, it's the foundation. From the simplest equations to the most complex geometries, math allows us to explore ideas that defy our everyday intuition, giving shape to concepts as abstract as parallel universes and alternate dimensions. Take probability theory, for example. At its core, this branch of mathematics deals with uncertainty, the likelihood of different outcomes. In the context of the multiverse, probability takes on a whole new meaning. Imagine flipping a coin. In our universe, it lands on heads or tails. But according to the many worlds interpretation, every possible outcome of that flip actually happens. It's just that each one occurs in a separate universe. Probability theory helps us quantify this branching, showing how every decision, every event could lead to an infinite web of realities. But math doesn't stop at probabilities. Geometry, especially in higher dimensions, plays a pivotal role in multiverse theories. Think about how we describe our everyday world: 3 dimensions of space, length, width, and height plus time. But what if there are more dimensions, ones we can't see or touch? String theory, for instance, relies on complex geometries with up to 11 dimensions to explain the fundamental forces of nature. These extra dimensions aren't just abstract ideas, they're mathematically necessary to make the theory work. And if they exist, they could be the key to understanding how multiple universes coexist, each one a unique configuration of space and time. One of the most fascinating mathematical tools in this exploration is the concept of manifolds. A manifold is a shape that, when you zoom in close enough, looks like ordinary space, like how the surface of the Earth seems flat when you're standing on it. In higher dimensional space, manifolds can take on incredibly complex forms, with folds, twists, and connections that defy visualization. These shapes aren't just theoretical, they're used to model how universes might interact or even collide in a multiverse. For example, the collision of 2 branes, those higher dimensional membranes we've discussed, could mathematically explain the Big Bang, the event that gave birth to our universe. Mathematical models also help us grapple with the sheer scale of the multiverse. Infinity is a tricky concept, but math gives us ways to work with it. Through set theory and calculus, we can explore infinite possibilities, infinite universes, and even infinite variations of physical laws. These models don't just describe the multiverse, they help us test its plausibility, providing a framework for physicists to explore ideas that might otherwise seem too abstract or speculative. Yet, for all its power, mathematics also reminds us of the limits of our understanding. Some multiverse theories rely on equations that are so complex, so far beyond our current computational capabilities, that we can only glimpse their implications. It's a humbling reminder that the multiverse isn't just a scientific idea, it's a mathematical frontier, a place where the known and the unknown meet. What's truly remarkable is how these abstract concepts can feel so tangible. When mathematicians and physicists work with equations to describe parallel universes, they're not just crunching numbers, they're building bridges between theory and reality. They're showing us that the multiverse isn't just a flight of fancy. It's a possibility grounded in the very fabric of mathematics, the language that underpins everything we know about the cosmos. So, the next time you hear about parallel universes, remember, behind every mind-bending idea is a mathematician, quietly working out the equations that make it all possible. Whether it's through probability, geometry, or higher dimensional models, math is the key that unlocks the door to the multiverse and invites us to step inside. Time moves forward, or at least that's how it feels to us. From the moment we wake up to the second we fall asleep, our lives unfold in a linear sequence: past, present, future. But what if that's just an illusion? What if time, as we know it, is more like a river with countless tributaries, branching off into parallel universes where the arrow of time points in entirely different directions? The idea that time might flow differently in alternate dimensions isn't just a wild thought. It's a theory grounded in some of the most cutting-edge physics of our age. Let's start with the concept of eternal inflation, a theory that imagines our universe as just one bubble in an endless cosmic foam. According to this idea, new universes are constantly being born, each with its own unique laws of physics. In some of these universes, time might flow backward. In others, it could loop endlessly, creating cycles of birth and rebirth. And in still others, time might not flow at all. It could exist as a static block, where every moment is equally real and present. This is the block universe theory, which suggests that past, present, and future aren't sequential but coexist, like frames in a film strip. But how does this affect our experience of time? If all moments exist simultaneously, then events we think of as past or future might still be happening right now, just in a different slice of reality. This could explain phenomena like déjà vu, that eerie feeling that you've experienced something before. Could it be that in a parallel universe you actually have? Some theorists suggest that déjà vu might be a fleeting glimpse into another timeline, where a nearly identical version of you is living out a similar moment. And what about precognition, the sense of knowing something before it happens? While often dismissed as pseudoscience, some interpretations of quantum mechanics open the door to the possibility that information from the future could leak into the present. If time is more fluid than we think, and alternate timelines are constantly branching off, it's not impossible to imagine that our brains might occasionally tap into these parallel streams, catching a glimpse of what's to come. These ideas don't just challenge our understanding of time, they reshape how we think about ourselves and our place in the universe. If time isn't a straight line but a sprawling web of possibilities, then every decision we make, every path we take, could be just one thread in a much larger tapestry. It's a perspective that invites us to see our lives not as isolated events but as part of an infinite, interconnected whole. As we explore these theories, one thing becomes clear: time is far stranger than we ever imagined. It's not just a backdrop to our lives, it's a dynamic, multidimensional force that might connect us to realities we can't yet perceive. The arrow of time, it seems, isn't just pointing forward, it's pointing everywhere. And who knows, maybe somewhere out there in a parallel universe, time is flowing in reverse, and the future is already written, waiting for us to catch up. If parallel universes exist, they don't just open up scientific possibilities, they force us to confront profound ethical questions that challenge the very foundations of how we think about morality, identity, and responsibility. Imagine a version of you in another universe who made a choice you would never make in this one. Are you accountable for their actions? Does their existence change how you define who you are? These aren't just hypotheticals, they're dilemmas that could reshape our understanding of ethics in a multiverse. Let's start with accountability. In our everyday lives, we hold people responsible for their actions based on the idea that their choices are their own. But what happens when those choices branch off into infinite realities? If every decision creates a new universe, does that mean there's a version of you out there who's committed acts you'd never dream of? And if so, does that dilute your sense of moral agency? Some philosophers argue that in a multiverse, responsibility becomes fragmented. each version of you is only accountable for their own choices, not those of their alternate selves. But others suggest that the very existence of those alternate choices could blur the lines of accountability, leaving us to question whether we're truly in control of our actions or merely passengers in a cosmic web of possibilities. This leads us to another thorny question: how do we define identity in a multiverse? If countless versions of you exist, each shaped by different decisions and circumstances, what makes you uniquely you? Is identity tied to the choices we make, the memories we hold, or something deeper, like a core essence that transcends individual realities? These questions aren't just philosophical musings, they have real-world implications. For example, if we ever develop the technology to interact with parallel universes, how would we treat our alternate selves? Would they be extensions of us or entirely separate beings with their own rights and autonomy? The ethical implications don't stop there. Consider the concept of harm. If every possible outcome exists somewhere, does that mean suffering is inevitable? In one universe, a decision might lead to joy and prosperity. In another, it could cause pain and loss. Does the existence of these alternate outcomes make suffering acceptable, since it's balanced by happiness in other realities? Or does it make our moral obligation to reduce suffering even more urgent, knowing that our choices ripple across countless universes? These questions also challenge traditional notions of justice and fairness. If every possible action is played out in some universe, how do we judge what's right or wrong? Does morality become relative, shifting with the circumstances of each reality? Or is there a universal ethical framework that applies across all dimensions? Philosophers and ethicists are still grappling with these ideas, but one thing is clear: the multiverse forces us to rethink not just how we live, but how we define what it means to live well. What's fascinating is how these ethical dilemmas connect to our everyday lives. Even without proof of parallel universes, the idea that alternate realities could exist invites us to reflect on our own choices and their consequences. It challenges us to consider the weight of our decisions, not just in this world, but in the infinite possibilities that might exist beyond it. As we navigate these complex questions, we're reminded that the multiverse isn't just a scientific concept, it's a mirror, reflecting our deepest questions about who we are and what we value. Whether or not parallel universes are real, the ethical challenges they pose push us to think more deeply about our place in the cosmos and the responsibilities we carry as conscious beings. And perhaps in exploring these ideas, we'll find new ways to approach the moral dilemmas of our own reality, not with certainty, but with curiosity, humility, and a willingness to embrace the unknown. The search for extraterrestrial life has always been one of humanity's most profound quests. We've scanned the skies, probed distant planets, and listened for signals from civilizations that might exist light years away. But what if we've been looking in the wrong places? What if the key to finding life beyond Earth isn't just across the vast expanse of space, but in the hidden folds of alternate dimensions? Parallel universes with their own unique laws of physics might be teeming with life forms so alien, so unimaginable, that they defy everything we know about biology and evolution. Think about it. In a parallel universe, the very building blocks of life could be completely different. Instead of carbon-based organisms as we have here on Earth, life might be built on silicon or even more exotic elements. The conditions for life as we know it, liquid water, a stable atmosphere, and a temperate climate, might not apply at all. In some universes, life could thrive in environments that would be instantly lethal to us, like the crushing pressures of a gas giant or the searing heat of a star's surface. These alternate realities could host ecosystems so bizarre, so alien, that they'd challenge our very definition of what it means to be alive. But how could we ever detect life in another dimension? The answer might lie in the strange and subtle ways that parallel universes could interact with our own. Some theories suggest that certain particles or forces might leak between dimensions, creating faint signals that we could potentially detect. For instance, if dark matter is indeed the gravitational shadow of another universe, as some scientists speculate, then studying it more closely might reveal clues about the nature of life in that reality. Imagine discovering a faint, rhythmic pattern in the behavior of dark matter, a pattern that suggests the presence of intelligent beings communicating across dimensions in ways we're only beginning to understand. This idea of interdimensional communication opens up a whole new frontier in the search for extraterrestrial intelligence. Instead of scanning for radio waves or looking for biosignatures, we might need to develop entirely new methods of detection. Quantum entanglement, for example, could play a role. If particles in our universe are entangled with particles in another, changes in one could instantaneously affect the other. Could advanced civilizations be using this phenomenon to send messages across dimensions? It's a tantalizing possibility, and one that could revolutionize our approach to the search for life beyond Earth. The implications of finding interdimensional life would be staggering. Not only would it expand our understanding of biology and evolution, but it would also force us to rethink our place in the cosmos. If life can exist in countless forms across countless realities, then the universe, or multiverse, is far richer, far more diverse, and far more interconnected than we ever imagined. It would mean that we're not just searching for life out there among the stars, we're searching for life in the spaces between realities, in dimensions we can't yet perceive. As we explore these ideas, we're reminded just how much there is to discover. The search for extraterrestrial life isn't just about finding answers, it's about asking the right questions. And in a multiverse filled with infinite possibilities, the questions we ask might be just as important as the answers we find. So, the next time you look up at the night sky, remember, the cosmos might be far more crowded than we think. The neighbors are out there, we just need to learn how to listen across the dimensions. Artificial intelligence is no longer just the stuff of futuristic dreams. It's a powerful tool reshaping the way we explore the cosmos. And when it comes to unraveling the mysteries of alternate dimensions, AI might be the key to unlocking doors we didn't even know existed. Imagine a technology so advanced that it can simulate entire universes, analyze their structures, and uncover hidden patterns that human minds alone could never detect. This isn't science fiction, it's the cutting edge of scientific discovery, where AI is becoming an indispensable partner in our quest to understand the multiverse. One of the biggest challenges in studying parallel universes is their sheer complexity. The equations that describe them are often so intricate, so layered with variables, that even the most powerful supercomputers struggle to process them. But AI thrives in this space. Machine learning algorithms, for example, can sift through massive datasets, identifying patterns and connections that might otherwise go unnoticed. Think of AI as a cosmic detective, piecing together clues from the fabric of reality to build models of how alternate dimensions might behave. Take the many worlds interpretation, for instance. Simulating every possible outcome of every quantum event would require an unimaginable amount of computational power. But AI can streamline this process by focusing on the most likely or interesting scenarios, helping researchers explore how branching realities might unfold. By running simulations of these alternate timelines, AI could give us a glimpse into what life might look like in other universes, whether it's a world where dinosaurs never went extinct or a reality where human civilization took a completely different path. AI's potential doesn't stop at simulation. It could also help us interpret the subtle signals that might hint at the existence of parallel universes. For example, anomalies in cosmic microwave background radiation, the faint afterglow of the Big Bang, could be evidence of interactions between our universe and others. AI algorithms trained to recognize these faint echoes might uncover patterns that human researchers would miss. It's like having a magnifying glass that can zoom in on the tiniest details of the cosmos, revealing secrets hidden in plain sight. But perhaps the most exciting possibility is how AI could help us test the untestable. Many theories about alternate dimensions, like string theory or the holographic principle, are incredibly difficult to verify experimentally. AI could bridge this gap by creating predictive models that simulate how these theories might manifest in observable phenomena. If an AI-generated model aligns with real-world data, it could lend credibility to ideas that were once considered purely speculative. Of course, AI isn't a magic solution. It's a tool, and like any tool, it has its limits. The algorithms are only as good as the data we feed them, and there's always the risk of bias or error. But when used thoughtfully, AI has the potential to revolutionize our understanding of the multiverse, offering insights that could reshape not just science, but our very perception of reality. As we look to the future, it's clear that AI will play an increasingly important role in exploring alternate dimensions. It's a partnership between human creativity and machine precision, a collaboration that could take us further than we've ever gone before. And who knows, the answers we're seeking about the nature of existence, the structure of the cosmos, and our place within it, might be closer than we think, waiting to be discovered by the next generation of AI-powered explorers. This fusion of technology and curiosity isn't just about solving puzzles. It's about expanding the boundaries of what's possible. With AI as our guide, the multiverse might not remain a mystery for much longer. As humanity sets its sights on the stars, the concept of parallel universes could redefine the very meaning of space exploration. Imagine a future where the boundaries of our universe aren't the final frontier, where wormholes, higher dimensional realms, and alternate realities become the next destinations for cosmic adventurers. This isn't just science fiction. It's a vision that could transform how we think about our place in the cosmos and where we might go next. One of the most exciting possibilities is the idea of wormholes as cosmic shortcuts. These theoretical tunnels through space-time, predicted by Einstein's equations, could connect distant points in our universe or even bridge entirely different realities. Picture a spacecraft entering a wormhole near Earth and emerging in a galaxy billions of light-years away, or perhaps even in a parallel universe with its own unique laws of physics. While the challenges of stabilizing and navigating a wormhole are immense, the potential rewards are equally staggering. It's a concept that pushes the boundaries of engineering and imagination, offering a glimpse of a future where the multiverse becomes our playground. But wormholes aren't the only path to alternate dimensions. String theory suggests that our universe might be just one of many branes floating in a higher dimensional space. These branes could exist mere millimeters away from us, separated by dimensions we can't perceive. What if future explorers could find a way to cross over into these neighboring realities? The technology required to access higher dimensions is far beyond our current capabilities, but the idea itself opens up a universe of possibilities. Imagine stepping into a reality where gravity behaves differently, where time flows backward, or where the very fabric of existence is unlike anything we've ever known. Of course, exploring the multiverse isn't without its challenges. The energy required to create or traverse a wormhole, for example, would be astronomical, literally. And the risks of venturing into unknown dimensions are equally daunting. What happens if you enter a universe where the laws of physics are incompatible with human life? Or if you become trapped in a reality with no way back? These are questions that scientists and engineers would need to address before multiverse exploration could become a reality. Yet, despite the obstacles, the idea of exploring parallel universes is deeply inspiring. It invites us to think beyond the confines of our own reality, to imagine a future where humanity isn't just exploring planets and stars but entire dimensions. It's a vision that challenges us to push the limits of science and technology, to dream bigger and bolder than ever before. This future also raises profound questions about the nature of exploration itself. If we discover alternate realities, how do we interact with them? Do we approach them as scientists cataloging their unique properties, or as explorers seeking to understand their inhabitants and cultures? And what responsibilities do we have to these other realities, especially if our presence could disrupt their delicate balance? As we ponder these questions, one thing becomes clear. The multiverse isn't just a scientific concept, it's a call to action. It challenges us to rethink what's possible, to expand our horizons, and to embrace the unknown with curiosity and courage. Whether through wormholes, higher dimensional travel, or technologies we've yet to imagine, the exploration of parallel universes could be the next great chapter in humanity's quest to understand the cosmos. So, the next time you gaze up at the night sky and wonder what lies beyond, remember, the universe might be just the beginning. The multiverse is out there waiting to be explored, and it's a journey that could redefine not just how we see the cosmos, but how we see ourselves. The concept of the multiverse doesn't just stretch the boundaries of science, it fundamentally challenges how we think about existence, reality, and even the meaning of life. If parallel universes truly exist, each with its own unique set of physical laws and possibilities, what does that mean for our understanding of the world? Philosophers have been grappling with these questions for decades, and their insights offer a fascinating lens through which to view the multiverse. Take David Lewis, for example, a philosopher who proposed the idea of modal realism. In his view, every possible world, every conceivable version of reality, is just as real as our own. This means that not only do parallel universes exist, but they exist in the same concrete way our universe does. It's a bold idea, one that forces us to rethink what we mean by real. If every possible outcome of every decision is playing out somewhere, does that make our choices less meaningful, or does it amplify their significance, knowing that every path we take creates a new reality? Nick Bostrom, another influential thinker, takes a different but equally provocative approach with his simulation hypothesis. He argues that if advanced civilizations can create simulations indistinguishable from reality, it's statistically likely that we're living in one. If true, this wouldn't just mean our universe is a simulation, it would imply that countless other simulated realities exist alongside ours. Suddenly, the multiverse isn't just a collection of physical worlds, it's a network of virtual ones, each with its own rules and inhabitants. This idea blurs the line between creator and creation, raising questions about who or what might be running the simulation and why. These philosophical perspectives don't just challenge our understanding of reality, they force us to confront the nature of existence itself. If the multiverse is real, does that mean we're just one thread in an infinite tapestry? Or does it give our lives more meaning, knowing that every choice we make creates a new branch of reality? Some philosophers argue that the multiverse actually enhances our sense of purpose, offering a cosmic stage where every decision, no matter how small, has profound consequences. Others, however, worry that it could lead to existential nihilism, where the sheer scale of possibilities makes individual actions feel insignificant. One of the most intriguing implications of the multiverse is how it reshapes our understanding of identity. If countless versions of you exist, each shaped by different choices and circumstances, what makes you uniquely you? Is it your memories, your personality, or something deeper, like a soul or consciousness that transcends individual realities? This question has profound implications not just for philosophy, but for ethics and morality. If your actions in one universe affect other versions of yourself, do you have a responsibility to them? Or is each version of you entirely autonomous, free to live their own life without interference? The multiverse also challenges traditional notions of time and causality. If every possible outcome exists simultaneously, does that mean the past, present, and future are all equally real? Some philosophers suggest that time itself might be an illusion, a byproduct of our limited perspective. In this view, the multiverse isn't just a collection of alternate realities. It's a timeless, interconnected whole where every moment coexists. This idea, known as eternalism, invites us to see our lives not as a linear sequence of events, but as part of a vast, multidimensional tapestry. As we wrestle with these questions, one thing becomes clear. The multiverse isn't just a scientific theory, it's a philosophical frontier. It challenges us to rethink everything we thought we knew about reality, identity, and meaning. And while we may not have all the answers, the journey to explore these ideas is itself a profound act of discovery. It's a reminder that the universe or multiverse is far richer, far more mysterious, and far more interconnected than we ever imagined. So the next time you ponder the big questions, who am I? Why am I here? Remember that the answers might not lie in this reality alone. They could be scattered across countless dimensions, waiting for us to find them. And in that search, we might just discover not only the nature of the multiverse, but the nature of ourselves. If every decision you make sends ripples through the fabric of reality, spawning countless parallel universes, does that mean you're truly free to choose? Or are your choices just following a script written by the laws of physics? The concept of parallel universes doesn't just expand our understanding of the cosmos, it forces us to confront one of the most profound questions in philosophy: the nature of free will versus determinism. On one hand, the many worlds interpretation of quantum mechanics suggests that every possible outcome of every decision actually happens, just in different universes. This might sound like the ultimate expression of free will, where every choice you make creates a new reality. But here's the twist: if every possible outcome is inevitable in some universe, does that mean your choices are predetermined? Are you simply following a path that's already laid out, branching endlessly into infinite possibilities? This debate has deep roots in philosophy. Determinists argue that every event, including human decisions, is governed by prior causes. In this view, free will is an illusion, a comforting story we tell ourselves to make sense of a universe that's running on autopilot. But proponents of free will counter that our ability to make choices, to weigh options and act on them, is real and meaningful. Parallel universes add a fascinating layer to this debate. If every decision spawns a new reality, does that mean you're exercising free will in every branch? Or are you just a passenger on a cosmic roller coaster with no control over where it goes? Some philosophers suggest that the multiverse offers a middle ground. In this view, free will isn't about breaking the laws of physics, it's about navigating them. Think of it like a tree with infinite branches. You can't control the tree's growth, but you can choose which branch to climb. Every decision you make is a step along a particular path, and while other paths exist, the one you're on is uniquely yours. This perspective doesn't just reconcile free will with determinism, it reframes the entire debate, showing how the two ideas might coexist in a multiverse. But let's take this a step further. If parallel universes exist, does that mean there's a version of you out there who made every possible choice? A version who became a doctor, a version who became an artist, a version who never left their hometown. If so, does that dilute the significance of your choices, knowing that every path is being explored somewhere else? Or does it amplify their importance because every decision creates a new reality with its own unique consequences? These questions don't just challenge our understanding of free will, they force us to rethink what it means to be human. They invite us to consider that our lives aren't just a series of random events but a tapestry of choices, each one weaving a new thread into the fabric of reality. Whether you believe in free will, determinism, or something in between, the multiverse offers a fresh perspective on one of humanity's oldest questions. Are we the authors of our own stories, or are we simply characters in a much larger narrative? As we wrestle with these ideas, one thing becomes clear. The multiverse isn't just a scientific theory, it's a mirror, reflecting our deepest questions about who we are and what we value. Whether or not parallel universes are real, the journey to explore them invites us to think more deeply about our choices, our agency, and the infinite possibilities that lie ahead. And perhaps in that exploration, we'll find not just answers, but a renewed sense of wonder at the complexity and beauty of existence itself. What if the very act of observing the world around us doesn't just record reality, it shapes it? This is one of the most provocative ideas in modern physics, and it brings us to the intersection of consciousness and the cosmos. At the heart of this concept is the observer effect, a phenomenon in quantum mechanics where the act of measurement fundamentally changes the state of a particle. But what if this isn't just a quirk of science? What if consciousness itself is a force that molds the fabric of reality, creating new branches of existence with every thought, every decision, every moment of awareness? Let's start with the double slit experiment, one of the most famous demonstrations of quantum weirdness. When particles like electrons or photons are fired at a barrier with two slits, they create an interference pattern on the other side, behaving like waves. But the moment you set up a detector to observe which slit the particle goes through, the interference pattern disappears and the particle behaves like a single, discrete object. This suggests that the act of observation, of consciousness, somehow collapses the wave function, forcing the particle to choose a state. But according to the many worlds interpretation, the wave function doesn't collapse at all. Instead, every possible outcome occurs, each in its own universe. So, what if consciousness isn't collapsing reality? It's splitting it. This idea leads us to the Or theory, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. They suggest that consciousness arises from quantum processes within the brain, specifically in structures called microtubules. If consciousness is quantum in nature, it could interact with the fundamental fabric of reality, influencing the branching of parallel universes. Imagine your thoughts and intentions as ripples on the surface of a quantum ocean, creating new realities with every ripple. It's a perspective that blurs the line between mind and matter, suggesting that our inner world might have a profound impact on the outer one. But consciousness isn't just about observation, it's also about intention. Some theories propose that focused thought or intention could influence the probabilities of quantum events, effectively steering the course of reality. This idea, while still speculative, has roots in experiments like the double slit experiment, where the presence of an observer changes the outcome. Could it be that our intentions, our desires, and even our beliefs shape the universe around us, not just metaphorically but physically? Of course, these ideas are met with skepticism. Critics argue that consciousness is too ill-defined to be a measurable force in physics, and that attributing such power to the mind risks veering into pseudoscience. But proponents counter that consciousness is one of the few things we truly experience directly. It's the lens through which we perceive reality. If it plays a role in shaping that reality, even in subtle ways, it would revolutionize not just physics but our understanding of existence itself. What's fascinating is how these theories connect to ancient philosophies and spiritual traditions, many of which have long proposed that consciousness and reality are deeply intertwined. From the Buddhist concept of dependent origination to the Hindu idea of Maya, the illusion of the material world, there's a recurring theme that reality is shaped by perception. Modern physics, in its own way, is beginning to echo these ancient insights, suggesting that the boundary between observer and observed might be far more fluid than we ever imagined. As we explore these ideas, we're reminded just how much there is to discover, not just about the universe, but about ourselves. Consciousness might be the most mysterious and powerful force in existence, a bridge between the quantum and the cosmic, the inner and the outer. Whether it's shaping parallel universes or simply helping us navigate the one we're in, its role in the fabric of reality is a question that continues to captivate scientists, philosophers, and dreamers alike. So, the next time you pause to reflect on your thoughts or marvel at the richness of your inner world, consider this: your consciousness might be far more than a passive observer. It could be an active participant in the unfolding story of the cosmos, a force that shapes not just your reality, but the infinite possibilities that lie beyond it. What if the truth isn't what we think it is? What if, instead of a single, unchanging reality, there are countless versions of the truth, each one real in its own universe? This is one of the most profound questions raised by the concept of parallel universes. The multiverse doesn't just expand our understanding of reality, it challenges the very idea of an ultimate truth, forcing us to rethink what we know, how we know it, and whether truth itself is as universal as we once believed. In our everyday lives, we tend to think of truth as something fixed and absolute. 2 + 2 = 4, the Earth orbits the Sun, and water boils at 100 degrees Celsius. These are truths we take for granted. But what happens when you introduce the possibility of alternate realities? In a parallel universe, the laws of physics might be different. 2 + 2 could equal 5, or the Earth might orbit a different star altogether. If every possible version of reality exists somewhere, does that mean every version of the truth is equally valid? This idea has profound implications for science, which is built on the pursuit of objective truths. If the multiverse exists, then the laws of physics we observe in our universe might not be universal. They could just be one set of rules among many. For example, the speed of light, the strength of gravity, or even the nature of time might vary from universe to universe. This doesn't mean science is wrong. It just means that our understanding of reality might be limited to the specific rules of our own universe. In a multiverse, the search for truth becomes more complex, more nuanced, and infinitely more fascinating. Philosophy, too, is deeply impacted by the idea of parallel universes. Thinkers like Immanuel Kant argued that our perception of reality is shaped by the structures of our minds, that we can never know the thing in itself, only our subjective experience of it. The multiverse takes this idea even further, suggesting that our experience of reality might not just be subjective but also contingent. What's true for us might not be true for another version of ourselves in a different universe. This raises questions about the nature of knowledge itself. If truth is relative to the universe you inhabit, can we ever claim to know anything with absolute certainty? But the implications of the multiverse aren't just abstract. They touch on our everyday lives in surprising ways. Consider the choices we make, the job we take, the relationships we build, the paths we follow. In a multiverse, every decision spawns a new reality, each one a different version of the truth about who we are and what we could become. Does that make our choices less meaningful, knowing that every possible outcome is playing out somewhere? or does it give them more weight because every decision creates a new truth, a new story, a new reality? What's truly fascinating is how these ideas challenge our sense of certainty. In a world where multiple truths coexist, the search for knowledge becomes less about finding the right answer and more about exploring the infinite possibilities of existence. It's a perspective that invites curiosity, humility, and a willingness to embrace the unknown. As we navigate these questions, one thing becomes clear: the multiverse isn't just a scientific theory, it's a philosophical and existential challenge. It forces us to confront the limits of our understanding, to question the nature of truth, and to consider that reality might be far more complex, far more diverse, and far more mysterious than we ever imagined. So, the next time you think you've found the truth, take a moment to wonder, is this the only version? Or is it just one thread in an infinite tapestry of realities, each one as real, as valid, and as true as the next? The multiverse doesn't just expand our horizons, it invites us to see the world and ourselves in a whole new light. Imagine having a key that could unlock doors to entirely new worlds hidden just beyond the limits of our perception. That's exactly what technology is becoming in the quest to explore alternate dimensions. From quantum computers crunching unimaginable calculations to particle accelerators smashing matter at mind-bending speeds, the tools we're building today are redefining what's possible in the search for parallel universes. These advancements aren't just expanding our understanding of reality, they're giving us the means to test theories that once seemed purely speculative. Let's start with quantum computing, a field that's revolutionizing how we approach complex problems. Traditional computers operate in binary zeros and ones, but quantum computers use qubits, which can exist in multiple states at once thanks to the principles of superposition. This means they can process vast amounts of data simultaneously, making them uniquely suited to tackle the intricate equations that describe alternate dimensions. For example, simulating the behavior of particles in higher dimensional spaces, a task that would take classical computers centuries, could be done in a fraction of the time with quantum systems. It's like having a telescope for the multiverse, allowing us to peer into realms that were once beyond our reach. But quantum computing is just one piece of the puzzle. Particle accelerators like the Large Hadron Collider are also playing a crucial role. By colliding particles at nearly the speed of light, these machines recreate conditions that existed just moments after the Big Bang. Why does that matter for alternate dimensions? Because some theories suggest that higher dimensions, if they exist, might leave subtle imprints in the debris of these collisions. For instance, if a particle were to leak into another dimension during a collision, it might produce anomalies in the data that scientists could detect. It's like searching for footprints in the sand, except the footprints might belong to a universe we've never seen. Then there's the role of space telescopes, which are helping us gather clues about the multiverse from the farthest reaches of the cosmos. Instruments like the James Webb Space Telescope are designed to detect faint signals from the early universe, including the cosmic microwave background radiation, the afterglow of the Big Bang. Some researchers believe that this radiation might contain faint echoes of collisions between our universe and others, like ripples from a stone dropped in a pond. By analyzing these signals, we might find evidence of other realities brushing up against our own. What's truly exciting is how these technologies are converging. Quantum computers can simulate the conditions of the early universe, particle accelerators can test those simulations, and space telescopes can provide real-world data to refine our models. It's a feedback loop of discovery where each tool builds on the others, pushing the boundaries of what we know. Of course, exploring alternate dimensions isn't just about building bigger and better machines, it's about asking the right questions. Technology gives us the tools, but it's our curiosity that drives the search. Every anomaly in a particle collision, every unexpected pattern in a quantum simulation, and every faint signal from deep space is a clue waiting to be deciphered. And while we may not have all the answers yet, the journey itself is transforming how we think about the cosmos. As we continue to develop these technologies, we're not just probing the edges of reality, we're redefining what it means to explore. The multiverse, once a concept confined to the realms of philosophy and science fiction, is now a tangible frontier, one that we're steadily inching closer to understanding. And with every breakthrough, we're reminded that the universe, or perhaps the multiverse, is far more vast, more complex, and more wondrous than we ever imagined. So, the next time you hear about a new quantum algorithm or a groundbreaking telescope discovery, remember, these aren't just scientific achievements, they're keys to unlocking the doors of existence itself. And who knows, the next door we open might just lead to a reality beyond our wildest dreams, time. It's the one thing we all experience, yet it's also one of the most enigmatic aspects of our universe. We measure it, plan around it, and feel its passage every day. But what if time isn't as straightforward as it seems? What if, in parallel universes, it behaves in ways that defy everything we think we know? This is where the nature of time takes a fascinating turn, challenging our understanding of reality itself. In our universe, time flows in one direction forward. We call this the arrow of time, and it's deeply tied to the second law of thermodynamics, which states that entropy or disorder always increases. This is why we remember the past but not the future, and why we can't unspill a glass of milk. But what if other universes don't play by the same rules? Imagine a reality where time runs backward, where entropy decreases and the future influences the past. It's a mind-bending concept, but one that some physicists take seriously. This idea isn't just speculative, it's rooted in the mathematics of general relativity. Einstein's equations allow for the possibility of closed time-like curves, or CTC paths through space-time that loop back on themselves, effectively allowing time travel. While CTCs are highly theoretical, they suggest that time might not be a one-way street in all universes. In some alternate realities, time could be cyclical, repeating endlessly like a cosmic loop. In others, it might not flow at all, existing as a static block where every moment, past, present, and future, is equally real. Then there's the concept of time dilation, a phenomenon well documented in our own universe. According to Einstein's theory of relativity, time slows down in the presence of strong gravitational fields or at high speeds. This means that an astronaut traveling near the speed of light would age more slowly than someone on Earth. Now, imagine this effect amplified in a parallel universe with vastly different physical constants. In some universes, time might crawl at a snail's pace, while in others it could race by in the blink of an eye. Entire civilizations might rise and fall in what feels like a single moment to us. But what about universes where time doesn't exist at all? This might sound impossible, but some theories suggest that certain dimensions could be timeless. In these realities, events wouldn't unfold in a sequence. Instead, everything would exist simultaneously, like a static image of eternity. Without time, there's no cause and effect, no aging, no decay, just an unchanging, eternal now. It's a concept that's almost impossible to visualize, but it raises profound questions about the nature of existence. These ideas don't just challenge our understanding of time, they reshape how we think about ourselves and our place in the cosmos. If time flows differently in other universes, does that mean there are versions of you experiencing life in fast-forward, slow motion, or even outside of time altogether? Could there be a reality where your past self is meeting your future self, or where every moment of your life is happening all at once? the possibilities are as thrilling as they are mind-bending. As we explore these theories, one thing becomes clear: time is far more mysterious than we ever imagined. It's not just a backdrop to our lives, it's a dynamic, multidimensional force that might connect us to realities we can't yet perceive. The arrow of time, it seems, isn't just pointing forward, it's pointing everywhere in every possible direction. And who knows, maybe somewhere out there in a parallel universe, time is flowing backward and the future is already written, waiting for us to catch up. So the next time you glance at a clock or feel the hours slip by, take a moment to wonder, what if time isn't what we think it is? What if it's a thread woven through countless realities, each one spinning its own unique story? The nature of time in the multiverse invites us to think bigger, to question deeper, and to embrace the infinite possibilities that lie beyond our everyday experience. Art has always been a mirror to the human imagination, reflecting our deepest questions and wildest dreams. When it comes to exploring alternate realities, artists have been at the forefront, using their creativity to paint, write, and compose worlds that stretch far beyond the limits of our own. From surreal paintings to mind-bending novels, the multiverse has inspired some of the most iconic works in history, offering a window into what might lie beyond the boundaries of our reality. Take Salvador Dali, for example, whose surrealist masterpiece, The Persistence of Memory, bends time and space like a dreamscape. The melting clocks draped over barren landscapes aren't just a visual trick, they're a meditation on the fluidity of reality itself. Dali's work invites us to question whether time is as rigid as we think, or if it's more like a malleable substance, bending to the whims of alternate dimensions. His art doesn't just depict alternate realities, it immerses us in them, challenging our perceptions of what's possible. Literature, too, has been a playground for exploring the multiverse. Jorge Luis Borges, in his short story The Garden of Forking Paths, imagines a labyrinthine novel where every possible outcome of every event unfolds simultaneously. It's a literary parallel to the many worlds interpretation, where every choice creates a new reality. Borges doesn't just tell a story, he crafts a universe of infinite possibilities, each one as real and as vivid as the last. Music also has its place in this cosmic exploration. Consider David Bowie's The Man Who Sold the World, a song that delves into themes of identity and alternate selves. Bowie's lyrics and persona often blurred the line between reality and fiction, as if he were channeling a version of himself from another dimension. His work reminds us that art isn't just about what we see or hear, it's about what we feel, and how those feelings connect us to something greater, something beyond. Even in modern media, the multiverse continues to inspire. The Marvel Cinematic Universe has brought the concept to the mainstream with films like Spider-Man, Into the Spider-Verse, and Doctor Strange in the Multiverse of Madness. These stories don't just entertain, they invite audiences to imagine what it would be like to meet alternate versions of themselves, to explore worlds where the rules are different, and to confront the infinite possibilities of existence. What's remarkable about these artistic explorations is how they resonate with both scientists and dreamers. They don't just depict alternate realities, they make them tangible, relatable, and deeply human. Whether it's through the brushstrokes of a painter, the words of a novelist, or the chords of a musician, art gives us a way to grapple with the vastness of the multiverse without losing sight of the emotional and philosophical questions it raises. By blending creativity with curiosity, artists help us see the multiverse not just as a scientific concept, but as a deeply personal one. They remind us that the search for alternate realities isn't just about understanding the cosmos, it's about understanding ourselves, our choices, and the infinite paths we might take. Through their work, we're invited to dream bigger, to question deeper, and to see the universe, and perhaps even the multiverse, as a canvas waiting to be painted. So, the next time you encounter a piece of art that transports you to another world, take a moment to wonder, is this just imagination, or could it be a glimpse into something real? After all, the line between art and reality might be thinner than we think, and the multiverse, in all its mystery, might be closer than we imagine. If the multiverse is real, it doesn't just expand the boundaries of reality, it shakes the very foundation of what we think gives life meaning. In a universe where every possible outcome exists, where every choice you make spawns countless alternate versions of yourself, what does it mean to live a meaningful life? Does the existence of infinite versions of you, each making different decisions, following different paths, diminish the significance of your own choices? Or does it amplify them, knowing that every moment is part of an infinite tapestry of possibilities? This idea challenges one of the most fundamental questions we ask ourselves: why are we here? In a single universe, we might find purpose in our relationships, our work, or our contributions to society. But in a multiverse where every possible version of those relationships, careers, and contributions exist simultaneously, the concept of purpose becomes far more complex. Some might argue that the multiverse makes life feel less unique, less special, that if every outcome is playing out somewhere, nothing truly matters. But others see it differently. They believe that the multiverse doesn't dilute meaning, it multiplies it. Every decision you make, every path you take, creates a new reality, a new story, a new version of you. In that sense, your life isn't just one thread in the fabric of existence, it's a kaleidoscope of infinite threads, each one vibrant and irreplaceable. Think about the choices that define your life, the career you pursued, the person you fell in love with, the risks you took or didn't take. In a multiverse, there's a version of you who made every possible choice. But here's the thing, this version of you, the one experiencing this moment right now, is the only one who gets to live this particular life. That makes your choices, your experiences, and your journey uniquely yours. The multiverse doesn't erase meaning, it reframes it, inviting us to see our lives not as isolated events but as part of a grand, interconnected whole. This perspective also invites us to reconsider what it means to live authentically. If there are infinite versions of you out there, how do you define who you are? Is it the choices you make, the values you hold, or something deeper, an essence that transcends individual realities? Some philosophers suggest that the multiverse actually enhances our sense of self, offering a cosmic stage where every decision, no matter how small, has profound consequences. Others argue that it challenges us to let go of rigid definitions of identity and embrace the fluidity of existence. What's fascinating is how these ideas connect to ancient philosophies and spiritual traditions. Many of these teachings emphasize the interconnectedness of all things, the idea that our individual lives are part of a larger, universal whole. The multiverse, in its own way, echoes this wisdom, showing us that our choices ripple across countless realities, shaping not just our own lives but the fabric of existence itself. As we reflect on these questions, one thing becomes clear. The multiverse doesn't just challenge our understanding of reality, it challenges our understanding of ourselves. It invites us to think bigger, to see our lives not as isolated stories but as part of an infinite, interconnected narrative. And in that narrative, every moment, every choice, every version of you has a role to play. So, the next time you find yourself pondering the meaning of life, consider this. The answer might not lie in a single, fixed truth, but in the infinite possibilities of existence. The multiverse doesn't just expand our horizons, it invites us to see our place in the cosmos with curiosity, humility, and a sense of wonder. After all, in a universe or multiverse filled with infinite possibilities, the search for meaning isn't just a journey, it's an endless adventure. Throughout history, religion has been humanity's compass for understanding the mysteries of existence, questions about where we come from, why we're here, and what lies beyond the veil of our reality. But what happens when the concept of parallel universes enters the conversation? How do ancient spiritual traditions, many of which predate modern science by millennia, reconcile the idea of alternate dimensions with their teachings about creation, divinity, and the afterlife? The intersection of religion and the multiverse is a fascinating space where science and spirituality meet, offering insights that challenge and enrich both perspectives. Take, for example, the concept of multiple heavens found in many religious traditions. In Christianity, the idea of a layered heavenly realm, often described as multiple levels or dimensions, echoes the multiverse theory in intriguing ways. The Apostle Paul, in his writings, speaks of being caught up to the third heaven, suggesting a reality beyond the physical world. Similarly, Islamic teachings describe 7 heavens, each with its own unique characteristics and purpose. These descriptions, while rooted in spiritual revelation, invite us to consider whether these heavens could be interpreted as parallel dimensions, realities existing alongside our own, governed by different laws and principles. Hinduism offers another compelling lens through which to view the multiverse. In this tradition, the universe is seen as cyclical, with endless cycles of creation, preservation, and dissolution. Each cycle, or kalpa, is said to produce countless worlds, each with its own unique characteristics and inhabitants. This concept aligns strikingly with the idea of an infinite multiverse, where every possible reality exists simultaneously. The Hindu text Vishnu Purana even describes multiple universes as bubbles floating in an infinite ocean, a metaphor that feels strikingly modern in light of current scientific theories. But the relationship between religion and the multiverse isn't just about parallels, it's also about tension. Some religious traditions emphasize a singular, divine creation, where the universe is a deliberate act of a higher power. The multiverse theory, with its infinite possibilities and branching realities, might seem at odds with this idea. Yet, others argue that a divine creator could just as easily design a multiverse as a single universe. In fact, some theologians suggest that a multiverse might even reflect the boundless creativity of a divine being, offering infinite expressions of existence rather than limiting creation to one reality. This interplay between science and spirituality also raises profound questions about the nature of divinity itself. If parallel universes exist, does that mean there are multiple versions of the divine, each interacting with its own universe? Or is there a singular, transcendent force that governs all realities simultaneously? These questions don't just challenge religious doctrine, they invite us to expand our understanding of the divine, seeing it not as confined to one reality but as something that transcends all dimensions. What's particularly fascinating is how these ideas resonate with modern scientific inquiry. The multiverse theory doesn't just challenge our understanding of physics, it invites us to rethink the very nature of existence, much like religion has done for centuries. Both science and spirituality, in their own ways, seek to answer the big questions. Why are we here? What is the nature of reality? And what lies beyond what we can see and touch? As we explore this intersection, it becomes clear that the multiverse isn't just a scientific concept, it's a bridge between disciplines, a space where the empirical and the mystical can coexist. Whether through the lens of religion or the rigor of science, the search for understanding is a deeply human endeavor, one that unites us in our curiosity and wonder. So, the next time you ponder the mysteries of existence, consider this. Perhaps the multiverse isn't just a challenge to our understanding of reality. It's an invitation to see the cosmos and our place within it in a whole new light. Through the dialogue between science and spirituality, we're reminded that the pursuit of knowledge isn't just about finding answers, it's about asking questions that inspire us to dream bigger and explore deeper. What if the key to humanity's future doesn't lie solely within our own universe, but in the infinite possibilities of the multiverse? As we stand on the brink of new discoveries, the concept of parallel universes isn't just a scientific curiosity, it's a roadmap for our evolution. From technological breakthroughs to profound shifts in how we see ourselves, the multiverse could redefine what it means to be human in ways we're only beginning to imagine. Imagine a future where technology allows us to interact with alternate realities. Quantum computing, for instance, could one day enable us to simulate entire universes, giving us a glimpse into worlds where the laws of physics are different or where history unfolded in unexpected ways. These simulations wouldn't just be academic exercises, they could spark innovations that transform our own reality. A parallel universe where energy is harnessed more efficiently, for example, might inspire breakthroughs in renewable energy here. Or a world where artificial intelligence has evolved differently could offer insights into creating more ethical and effective AI systems. The multiverse, in this sense, becomes a vast library of ideas, a place where the boundaries of human ingenuity are constantly being pushed. But technology is only one piece of the puzzle. The multiverse also challenges us to rethink our place in the cosmos. If countless versions of humanity exist, each shaped by different choices and circumstances, what does that mean for our collective identity? Philosophers and ethicists are already grappling with these questions, exploring how the existence of alternate realities might influence our sense of morality, responsibility, and purpose. Could the multiverse inspire a more compassionate worldview, where we see ourselves as part of an interconnected web of possibilities rather than isolated individuals? Or might it lead to existential questions about the meaning of our choices, knowing that every decision spawns new realities? This idea also has profound implications for our understanding of time and progress. In a multiverse, the linear narrative of history, where events unfold in a single, fixed sequence, gives way to a more dynamic, branching model. Every moment becomes a crossroads, a point where the future splinters into infinite possibilities. This perspective could reshape how we approach challenges, from climate change to social justice, by encouraging us to think beyond the constraints of a single timeline. What if solutions to our most pressing problems already exist in other universes, waiting to be discovered? And then there's the question of exploration. If parallel universes are real, could they become the next frontier for humanity? Just as we've set our sights on Mars and beyond, future generations might dream of traveling to alternate dimensions, not as science fiction but as a tangible goal. The technologies required for such journeys, wormholes, higher dimensional travel, or even consciousness-based exploration, are still in their infancy, but the very idea of multiversal travel sparks the imagination. Imagine stepping into a reality where ancient civilizations never fell, or where humanity evolved in ways we can't yet comprehend. These journeys wouldn't just expand our horizons, they could fundamentally change how we see ourselves and our potential. What's truly inspiring about the multiverse is how it invites us to dream bigger. It's not just a scientific theory, it's a call to action, a reminder that the universe, or multiverse, is far more vast, more complex, and more wondrous than we ever imagined. As we continue to explore these ideas, we're not just uncovering the secrets of existence, we're redefining what it means to be human. So, the next time you think about the future, consider this. The multiverse isn't just a concept to be studied, it's a canvas waiting to be painted. And as we stand at the threshold of this new frontier, one thing is certain: the journey ahead will be as thrilling as it is transformative. As our journey through the mysteries of parallel universes and alternate dimensions comes to a close, one undeniable truth stands out. reality is far stranger, richer, and more intricate than we've ever dared to imagine. From the mind-bending principles of quantum mechanics to the speculative edges of string theory, we've ventured into realms where the rules of existence seem to bend, twist, and sometimes shatter entirely. These ideas don't just challenge our understanding of the cosmos, they invite us to reimagine what it means to exist within it. Think about the implications of what we've explored. The many worlds interpretation suggests that every decision you make spawns a new reality, creating an infinite tapestry of possibilities. String theory paints a picture of higher dimensions where entire universes might exist mere millimeters away, hidden from our perception. And the simulation hypothesis dares us to ask, could everything we know be part of an elaborate construct, a digital playground crafted by an advanced civilization? These aren't just abstract concepts, they're invitations to expand the boundaries of our imagination, to see the universe as a place of limitless potential. But perhaps the most profound takeaway from this exploration isn't just the science, it's the questions it raises about who we are and our place in the cosmos. If alternate realities exist, does that change how we view our choices, our identities, or even our purpose? These are questions that bridge the gap between science and philosophy, reminding us that the pursuit of knowledge isn't just about finding answers, it's about learning to ask better questions. What's truly remarkable is how these ideas have permeated not just science, but art, culture, and even spirituality. From the surreal brushstrokes of Dali to the cosmic storytelling of Marvel, the multiverse has captured our collective imagination, offering a lens through which we can explore the infinite possibilities of existence. It's a testament to humanity's unquenchable curiosity, our drive to push beyond the known and venture into the unknown. As we wrap up this journey, let's not forget the spirit of exploration that brought us here. Whether or not parallel universes exist, the very act of imagining them has enriched our understanding of reality and inspired us to dream bigger. It's a reminder that the cosmos is full of mysteries waiting to be uncovered, and that every question we ask brings us one step closer to unraveling its secrets. Thank you for joining us on this mind-expanding adventure. If you've enjoyed this deep dive into the multiverse, don't forget to like, share, and subscribe for more explorations into the wonders of the cosmos. Until next time, keep questioning, keep exploring, and keep dreaming of the infinite possibilities that lie just beyond the horizon of our understanding. The universe, or perhaps the multiverse, is waiting.